Okay, boys and girls, welcome to our very first video lesson in Chapter 3, our lesson on lines on a plane. Lines on a plane and the angles they form. Make for a very good story. All right, stop the tape if you need to, but I'm going to run through these definitions with you real quick. Some of them you all already know. Certainly you already know a plane. It's a two-dimensional flat surface determined by three non-collinear points. Okay, coplanar, of course, means on the same plane, and non-coplanar, of course, is the opposite of that, not on the same plane. Okay, skew lines are non-coplanar lines. I can't draw them because they're not on the same plane. So I can't draw an example of non-coplanar lines, but an example would be two highways that don't intersect because they cross each other at an overpass. Okay? So non-coplanar lines are lines that do not cross, but they are also not parallel. Okay? Parallel lines, of course, are on the same plane. They are coplanar lines that do not cross. The symbol for parallel is that equal sign turns on its side. Those are parallel lines that do not cross. Lines D and E are examples of parallel lines. Okay? Perp and oblique lines are coplanar lines. So again, these are both coplanar. If they were non-coplanar, they would be skew. Coplanar lines that do cross are either perpendicular, which of course cross at right angles, and we know the symbol for perp, that's that brown upside down T. And oblique lines are lines that cross non-perpendicularly, so they cross on angles that aren't a right angle. Okay? So basically right now you know four types of lines, or four relationship between a pair of lines. Lines are either skew, they don't cross, but they're not on the same plane. They're parallel. They don't cross, but they're on the same plane. They're perp. They cross at right angles. Or four, they are oblique. They cross at non-right angles. Okay, a new word and a new picture, transversal. Transversals are a third line that intersects two other lines. Often my two other lines are parallel, but they don't have to be. Okay, so line A and line B are intersected by line C. Line C would be my transversal for lines A and B. And again, if I draw this line and this line, these two lines are parallel, my transversal would be this red line right here. Okay, there's my transversal. Notice that it's crossing those two parallel lines. Okay, so there are a bunch of different angles that you need to learn, the names of them. The names are scary, but really if you read the words carefully, you'll see that the words just tell you what the angles are. The first example is alternate interior angles. Okay, alternate interior angles. I'm just getting a purple pen here. Okay, alternate interior angles are angles that form the letter Z. And I'm trying to get rid of, here, I'm going to pause for a minute. Okay, alternate interior angles are a pair of angles when two lines are cut by a transversal. So again, I got line 1 and I got line 2. They are cut by my transversal, which is line 3. So here's my transversal right here at line 3. Okay. Angles 2 and 6. So this angle combined with this angle are an example of alternate interior angles. So they are on alternate sides, so opposite sides of my transversal, and they're on the interior, the inside of my parallel line. So they're on the inside of the parallel lines, and they're on the opposite sides of my transversal. 3 and 7 are the exact same thing. I'm going to change my color here to red just so you can see it. 3 and 7 are on opposite sides of my transversal, and they're both on the interior of my of my parallel lines. The easier way to remember The easier way to remember these angles is by the letter that they make. The alternate interior angle, so if I look at angles 3 and 7, do you see that Z right there formed by the angles 3 and 7? They form a Z, okay? I can also look at, for example, in green, angles 2 and 6. So 2 and 6 also are going to form that Z. It's a little stretched out Z, but it does make a Z. Alternate interior angles. We then got alternate exterior angles, which in this case could be angles 4 and 8. Angles 4 and 8 are exterior because they are on the outsides of my parallel lines. Notice that they're on the outside of the parallel lines. And again, one is on the top of the transversal and the other one, number 4, is on the bottom of the transversal. So they're alternate exterior angles. And the picture you want to think of is two birds flying away from each other. Do we see, and I'm just going to go to a highlighter here so you can see it. Do we see in angles 8 and 4, two birds flying away? Or if I want to, I can go to angles 5 and 1. Those are also alternate exterior angles. Do we see the two birds flying away from each other? Okay. Corresponding angles make the letter F. They're examples of angles where they are both on the same side of the transversal, but one is interior and one is exterior. So for example, if I look at angles 2 and 4, so this angle with this angle, do we see the letter F? And I'm going to make the letter F here in dark green. There it is. There's my letter F. That is the symbol or the signal for corresponding angles. We also have same side interior angles. Same side interior angles are on the same side of the transversal, but they're both inside. They're on the interior of the parallel lines. They make the letter C. So an example could be angles 7 and 6. Do we see the C right there? The other ones could be angles 2 and 3. I'll do that in green. That's right there. And again, we have a C. And the last pair of angles are same side exterior. Okay, they're birds flying away. I don't know, but they're different. But there is a picture. For you. So, for example, angles 1 and 4 are same side. Notice they're on the same side of my transversal. One is, and they're both outside. They're both outside. Same side. They're both on the bottom side. Same side exterior. Okay, so angles 5 and 8 would also be same side exterior because they are on the top side of my transversal, and they're both outside of the parallel lines. So let's play a quick little game. You guys name the type of angle for 5 and 7. If I look at angles 5 and 7, I'm going to highlight my angles right now. It looks like I see the letter F. So therefore, these two angles are corresponding angles. So these angles are corresponding. And 6 and 7, let's erase for a moment. 6 and 7. Angle 6 is right there. Angle 7 is right here. Looks like I got a letter C. Okay, the letter C tells me that these angles are same side interior. Okay, you guys, we'll try some more in class. One more quick theorem I need to give you. It's called the triangle exterior angle inequality theorem. Or if you want, you can call it the TIT. The TIT. Okay? Boys, don't chuckle. All right. So, the triangle exterior angle inequality theorem says if I have an exterior angle of a triangle, for in this case, angle 1, it is going to be greater than any of the remote interior angles. So as we look at angle 1, it's going to be bigger than angle 2. That's a remote interior angle, meaning the non-adjacent angle. And it's also going to be bigger than angle 3. So angle 1 is going to be larger than any remote, meaning not adjacent to it. 4 is adjacent to 1. Okay, but angle 1 is going to be larger than any of the remote interior angles, which in this case is angle 2 and angle 3. We call this the triangle exterior angle inequality theorem. Okay, now be careful, because as you look here, you can see now angle 1 is not greater than 4, but 4 is not a remote interior angle. But the triangle exterior angle inequality theorem says that 1 is bigger than 2. I should probably write it with angle symbols, because 1 is not bigger than 2, but angle 1 is bigger than angle 2, and angle 1 is bigger than angle 3. Okay, even though angle 1 is not bigger than angle 4. We will prove this theorem in class, I promise you. And I think we are done. Hey, have a great night.